So this is the piece that we call the invention, where we have a patent on. And essentially we've built it to be as efficient as we can in terms of the overall energy of the water system. Blair has sort of been the one who's put this together, and we're here today, of course, in the eco-hydraulics room in the University of Idaho in Boise. But Blair can probably explain the parts since he's kind of put the pieces together. So.
Okay, we've mounted this device on a PVC pipe, and right here we have a little propeller, and the propeller turns a shaft which turns this diaphragm pump. The diaphragm pump, as it operates, draws water from the intake tube and pushes it out into a water sample unit. We have a little sensor here which picks up a little magnet that's mounted onto the little propeller, and you can see the magnet right there. Every time the magnet comes around and passes under this sensor device, it gives it a pulse, and the pulse is picked up by the data logger unit, and from that we can determine the speed that the propeller is turning over a period of time and determine what the water velocity is. So this device, it has two purposes. It can measure the water velocity, and it can also pump water for water samples.
So this is a prototype of a flow proportional sampler that was developed at the University of Idaho in an engineering capstone project several years ago. We started with this design knowing that essentially in order for us to quantify flow and concentrations in the stream at an economical way, there is basically nothing available commercially to make this easily done in remote areas. I mean, if you look at it commercially, we pay more than $3,000 for a system that's equivalent to what we have here now. So essentially what you see in the flume is the piece that we invented. It has inside the little tube a little propeller which has a little magnet on it which tells us how many revolutions it's had. So it acts as a flow meter to determine the flow velocities in the water. So the water, of course, comes in from the flow sampler through a plastic tube, and it also has an electrical wire that comes down from it, which is connected to the data logger. And as the propeller is spinning, it sends pulses to that data logger, which in turn will go in and determine where the sample will go. Either the sample goes right back to the stream in cases where we do not need the water. If we've determined in our program within the data logger that we do want the water, then it goes into the flow bottles. And there is a little mechanism inside that actually is rotating the sampling to direct it to a different bottle every time. So we can actually collect multiple bottles for a flow event or multiple bottles over an extended period of time. So the big advantage of this is that it's driven by the power of the water. So we don't have to carry batteries into the field and essentially kind of leave it alone for a longer period of time. The overall system right now is just, as I said, a prototype, so there's definitely an opportunity to improve on this system, but it's already showing that it's working really well in simple systems like this.